In this part, we'll talk about the difference between a population and a sample. A population is the entire group that we want to draw conclusions about, whereas a sample is a specific subset from that population, and it's supposed to be a representative subset from that population, from which we are going to collect data to make conclusions about the whole population. So again, the first consideration is that the sample should be representative of the population, in the sense that if there was some variation in the characteristics of the population, then the sample should be able to reflect that properly. Another consideration is that the population doesn't always have to be about people, right? The population could be places of some kind. It could be animals. It could be objects, anything. So the population doesn't have to be always people. A third consideration is that the population doesn't necessarily have to be too big. All right, so maybe a classroom of 20 students could be considered a population, right? So it depends on your definition of the population or the characteristics that the population of interest has. Now, it's important to keep in mind that the data collected from the whole population will always produce more accurate results than the data collected from a sample. So the question that poses itself is, why do we collect data from a sample rather than the population? The main reason is that it's infeasible and probably impossible to collect data from the whole population in terms of money, effort, and the time spent. Right? So what we do is that we simply draw a sample from the whole population, a representative sample. We collect data from that sample, and then we make the different analyses to come up with conclusions about the whole population. Now, here are some examples of population sample pairs. So here, the population could be simply the students in a specific school called ABC, for example, right? And the sample simply could be 50 or 60 students from that school. Now, from these 60 students, we collect some data, right? We measure a specific characteristic, like for example, the mean or the median or the standard deviation of a specific characteristic, right? And then make conclusions about the whole school. Another example here, the population could be maybe the insects in a jungle in Australia. So can you see how specific I got here? Again, the population could be insects in a jungle in Australia. From this population, we can collect a sample of maybe 200 or 300 insects, right? Take our measurements, collect our data, and then make conclusions about the whole population of insects in the jungle in Australia, right? It could be, for example, the conclusion or the measurable characteristic could be the mean lifespan or the standard deviation of lifespan for these insects. A third example could be the musical instruments used in a specific type of a music or genre, right? From all these instruments, we can collect a sample of maybe 10 instruments, collect data from that sample, and then again make conclusions about the whole population of musical instruments. There are so many other examples, and I encourage you to look them up on your own just to see the diversity of possible populations. All right, so a couple of distinctions we want to make when it comes to populations and samples, starting with the symbols used for each. Before we get into that, it's worth noting that any measurable characteristic of a population is called a parameter. whereas any measurable characteristic of a sample is called a statistic. All right, again, statistics are for samples, parameters are for populations. All right, now let's start with the symbols. Normally, when we write equations to find certain parameters, capital N represent the sample size. Sorry, the population size. All right, whereas the small letter n represent the sample size. Okay. Second, the mean. We use the mu symbol to represent the mean of a population, whereas we use x bar, right, to represent the mean of a sample. For variance, we use sigma squared to represent the variance, whereas we use s squared to represent it for a sample. Finally, standard deviations, it's simply the square root of the variance is sigma. And for the sample, it's the square root of s squared, so the standard deviation in this case will be s or capital S. Another distinction is the equations used in order to obtain the different parameters and statistics. Starting with the size, as we know, n capital is for a population, whereas n small is for sample. For the mean, it's simply the sum of the observations divided by their number. So let's assume that we had these observations, 1, 3, 4, and 5. If this was the whole population, right, then we will sum up these values and divide them by their number, in this case, 4, right? Keeping in mind that xi, all right, represents each observation from 1 all the way to n, right? So this is x1, this is x2, this is x3, and this is x4. So we will take the sum of xi, where I starts from 1 and terminates at n. After we take the sum, we will simply divide by the number. Now this should be capital N, as we agreed before, since it's a population, right? Whereas when we talk about a sample, right, it's simply the same thing, right? But with slight differences in the symbols used. Okay, now we go to the variance. The variance, as we talked about before, is simply the average difference between the observations and the mean, or the average squared differences of the observations from the mean. In the first case, we sum all the differences, squared differences, and then we divide them by n, or the number of observations. However, for a sample, we simply divide by n minus 1. So it's not n, it's n minus 1. All right. And finally, the standard deviation is simply the square root of the calculated variance. So this is the same as this, and this is the same as this. So just make sure to notice the different symbols used and the slight differences in the equations we use to obtain the different statistics or parameters.